Hello everyone, myself Ashutosh Sadaria and this is 5th video of computer maintenance and troubleshooting series. In this video we are going to learn about functional block diagram of motherboard. First of all, what is functional block diagram? Functional block diagram describes different functional blocks of motherboard and how they are connected with each other. So let's see the diagram first. All of the components are connected by bus subsystem. You can see on the left of bus subsystem are processor and coprocessor, which are connected with interrupt controller and clock generator. And on the right side of the bus subsystem, you can see DMA controller, timer counter, ROM, DRAM and PPI. All are connected with expansion slots and bus subsystem through one channel. And by observing the diagram, you can see that all of the arrows are bidirectional. That means all of the data flows are between all of the components are bidirectional data flows, and only one component ROM has data flow as single unidirectional, that is outward from ROM. Because ROM is read-only memory, you cannot write data into the ROM. So that's why arrow is going out from ROM, because data is reading from ROM. You cannot write data into ROM. The first component of motherboard is processor. Processor is single chip which controls arithmetic and logical operations of your computer system. It is also referred as a central processing unit because it is in center of all the programming of your computer, and it is also called your brain of your computer. It contains two main sections of your computer. First is control unit and second is arithmetic and logical unit. There are several companies which makes processor like Intel, AMD, Cyrix, VIA. The second main component is coprocessor. Coprocessor is used to help processor to perform specific operations of your computer. The primary advantage of coprocessor is to reduce load on your microprocessor and speed up your execution of your day-to-day task. In the newer processors, the coprocessor is inbuilt into the chip of main microprocessor. The next component of motherboard is clock generator. Clock generator generates clock signal. All the logical elements of a computer are designed to perform their task in a synchronized manner. Clock generator is used to create single frequency. In that frequency, all of the devices are working in synchronous manner to perform different tasks of computer. This type of signals are generated by clock generator's logic. There are three different blocks of clock generator. The first is clock logic, the second is ready logic, and third is reset logic. Clock logic generates clock signals. Ready logic indicates the processor that the component is in ready state to receive data or perform certain tasks, and reset logic generates reset signal to the processor so that processor can restart the work from scratch. The next component is programmable interrupt controller. Interrupt controller handles all the interrupt generated by different devices and processor also. Interrupt are generated to capture the processor's attention and temporarily divert it to a different process. The interrupt controller handles up to 8 maskable interrupts from IR0 to IR7. The next component is bus subsystem. Bus is nothing but set of wires and tracks on motherboard. In motherboard, from one component to other component, information pass through bus. There are different types of bus on motherboard like data bus, address bus, control bus, memory bus, processor, etc. Bus controller generates control signals to control all of the devices connected to the bus. The next component is DMA controller. To speed up the system performance, the main processor is required to be relieved from time-consuming jobs like processing large amount of data from one place to another. The DMA controllers handles those tasks separately. DMA controller receives instruction from CPU. It performs all the tasks related to data moving, and after the completion of all the tasks, DMA controller informs CPU that the operation of data transfer has been completed. The next components are ROM and RAM. As you all know about ROM and RAM, ROM is read-only memory and it stores data permanently, and RAM is random access memory and it stores data temporarily. The next component is Programmable Peripheral Interface. Programmable Peripheral Interface connects all the peripheral devices and it relays data from all the devices to processor. There are three parts of PPI. First is port A. It is 8-bit port used to connect keyboard interface. The next is port B. It is used to interface and read status of DIP switch channels. Port C is 4-bit plus 4 bits. It means there are two different ports of 4 bits. Those ports are used for sending other control signals. The last component is expansion slots. Expansion slots are connected on your motherboard and on the back of your computer, which are used to connect different expansion cards like display card, sound card, network card, graphics card, etc.
Here are some of the important questions from the video. What is the use of bus subsystem? List out different signals generated by clock generator. What is the main use of coprocessor? DMA controller is used to eliminate which component? List out different parts of programmable peripheral interface. How many different interrupts are handled by interrupt controller? Which types of card you can connect to an expansion slots?
So that's all for today's video. Hope you understood different functional blocks of motherboard.